now it's time for everyone's favorite part. Rules. We get to learn the rules. What? Okay, so I told you that if you have a function and you're finding the derivative, the f prime, you take the exponent, you put it down, and you keep the x, and you minus 1 on the exponent, right? So you have 1, which is the same as not having 1, right? But what do you do if f of x is 2x squared? Oh my goodness, what are you supposed to do? Well, you take the exponent down, still, that doesn't change, but it multiplies to the 2 now. Instead of just becoming the 2, you multiply it with the 2. So you 2 times 2, you have 4, and everything else is the same. You have x and you have nothing. So if your f of x is, I don't know, 4x to the power of 3, f prime of x, you're going to multiply the 4 into 3. You're going to get 12x, and then 3 minus 1, you're going to get squared. So it's pretty much the same, but you just multiply it to whatever the coefficient is in front. And then what do you do if there's no exponents? There's no exponents at all. If you just have f of x equals 2, what is f prime of x? Oh my goodness. It's 2, guys. It's just 2. I mean, the logical way of this is x to the 1, right? So we multiply the 1 by the 2, and it would stay the 2, and then it become x to the 0. And x to the 0 is just 1. So it's just 2 times 1. Because anything to the power of 0 is 1. So it just stays 2. Or, if you don't want to do a whole bunch of algebra, you could just say, okay, there's no exponent, you just get rid of the x. So if f of x is 3x, f prime of x is 3. If f of x is 17,000x, f prime is just 17,000. Like, you just, if there's no exponent, you just get rid of the x. That's it. It's pretty simple. What do you do if there's no x at all? Oh my goodness. That's so crazy. What do you do if there's no x? If you have f of x equals 7, f prime of x is just 0. Anytime it's a constant, it's just 0. If this is 18, this is 0. This is 1, this is 0. This is 0, this is 0, right? Anytime there's no x or no variable at all, the derivative is just 0. The math explanation for that, if you want to get boring, right? If you have a function, if you have f of x equals, let's say 2, right? And there's no x, wow. The graph of this at 2, there's going to be a straight solid line at 2 that never changes. And if it never changes and it's just always at 2, it changes this a little bit because I drew a little slanted. But if it never changes and it's always at 2, the slope of this at any point, if you pick any point on here, on this line, right, and you find the slope is going to be 0. So that's why the f prime of x of any just number is just 0, because there's no slope. So if you're finding the slope of anything, if there is no slope, there's no slope. Like, it's just 0. But one more rule. This is the last one before we get to the big rules. These are the basic rules. I should have specified. So if you have 2 terms, what if there's multiple terms? If you have f of x equals x squared plus 3x plus 7, right? What do you do if there's multiple terms? All you do is you just derive them each individually and just keep the pluses and the minuses. So if you have f of x of this function, first term, bring the exponent down, 2, keep the x, plus 3x with no exponent is just 3, plus 0, because there's no variable here. So that's all it is. You just do them all individually. This is how you find the derivative of your functions, the f primes of your functions, the slopes of your functions. So let's look at a couple examples, because this is a brand new concept and this is an actual calculus concept. It's a crazy calculus concept never seen before. So f of x equals, we'll go 4x squared plus 8x minus 200. What is the instantaneous rate of change when x equals 4? If that was on your test, what is the instantaneous rate of change when x equals 4? What are you going to do here? Well, first you have to find the derivative, the instantaneous rate of change function, right? F of x equals, okay, 4x squared. Bring the exponent to the 4, you get 8. Keep the x, 2 minus 1, no exponent, or it's 1. Plus 8x, just put the 8, x goes away. Minus, this is, where's the variable at? Where's it at? This is 0. So you have 8x plus 8. Now you're going to plug in the 4, because you're trying to find f prime of 4. You're trying to find the instantaneous rate of change at 4. So 8 times 4 is 32 plus 8. So your instantaneous rate of change at 4 is 40. Okay, so if you have this problem here, what would you do? I know this is dy over dx, and this is y now, right? What does that mean? All this is, dy over dx is the exact same thing as f prime of x. There's just different ways of writing it. It's literally just the derivative. Is dy over dx, what this is. Y is the same as f of x. This, you should have already known that one. Okay, so find the derivative of this. Pause it. Take your little pause break and solve it. Okay, I'm assuming y'all paused it by now. 2x5 exponent. So 10x 5 minus 1 is 4 minus x to the third. Bring the 3 down. 3x 3 minus 1, you have 2 plus, okay, 4x. X goes away, it's the derivative. 4 plus, this is a constant, no variable, 0. So dy over dx equals this. So those are the basic rules of derivatives. Those are what derivatives are. Yeah, we moving on. Okay, we're gonna go over 2 more. These ones are gonna be hard. If you have f of x equals 2 over x, and f of x equals square root x. How would you solve these? How would you? This is unprecedented territory, right? Not really. So 2 over x is the same thing as 2x to the negative 1. Because if it's down here, that's what the negative 1 exponent means. It means you move it down to the denominator. So now you just solve it as normal. So f prime of x is negative 2x to the negative 2, right? Because negative 1 times 2 and the negative 1 minus 1, right? This isn't, you're not done. Because if it's negative 2, you have to simplify. You have to move it back down to the denominator. So you have negative 2 over x squared. And this is going to be your answer. So anytime it's a fraction and the x is on the bottom, you bring it back up to the top and give it a negative exponent, and you just solve it like normal. Okay, what about this one on the right? You know, square root x. What does that mean, right? So something square rooted is the same as having an exponent of 1/2. So square root of x is the same as x to the power of 1 over 2. And then you would solve this as normal. You would have 1/2 because you're bringing the exponent over. X, 1/2 minus 1 is negative 1 over 2. So what does this mean, right? What do you do with this? You're almost done, but you're not. So this is a negative exponent, so it moves to the bottom. So you have 1 over 2x to the 1 over 2. And x to the 1 over 2 is just square root x. So you're left with 1 over 2 square root x. And that's it. Yeah, so those are all the basic rules. Yeah, we moving on.